Today we're going to work on graphing polar functions. Now, to graph polar functions, we need two things. We need a radius, which we call r. Now, to get the radius, we're going to look at the angle, which is for us theta. Now, the first type of polar we'll take a look at are circles. Now, we recall earlier that circles from geometry is x squared plus y squared equals r squared. Or like if we had like some generic one, x squared plus y squared, let's say equals 16. From the other day, we learned that x squared plus y squared is the same as r squared equals 16. So if I were to graph this circle, this is a circle with a radius of 4. We don't worry about the plus or minus because radius is a number, is always positive. So I go 4 in every direction from our center, like so. Very easy to do. Now, there is another way we can take a graph a circle. What if the circle is not centered around the origin? And that's what we're going to take a look at for the next two examples. Now, the first one, graph the polar function r equals 4 sine of theta. And it tells us to make a table of values. And this is very easy to do. We're going to make a table. To find r, we need some theta. And we're just going to pick some angles. Now keep it in radians. So for the first one, I'll pick 0. If I'm at 0, remember, what that tells me is I'm facing 0. I want to find out how far out I go. So to do this, I go 4 sine of 0. Well, sine of 0 is 0, so this goes 0. So as a point, that is r theta, we can go 0, 0. So this keeps me at the origin, basically. Let's try another one. Let's try pi over 4. Go 4 sine pi over 4. So 4, this becomes root 2 over 2. So we get 2 root 2. So we're facing the pi over 4, and we go out 2 root 2, which is just a little bit past 2. So something like right here. Maybe. Now, I'm going to connect these two. Now, when you connect these, they make a sweeping motion. Think of a windshield wiper. And that's how these go. So I'm connecting. It's going to connect. It's going to make a sweeping motion. It's going to circle up. Now, if I try pi over 2, well, let's try that. Well, what's the sine of pi over 2? It's just 1, so this just becomes 4. So I'm facing pi over 2, I'm up to 4. 1, 2, 3, 4. And I'm going to keep it going to pi over 4. Well, let me try 3 pi over 4. Well, if I try this, I get 4 sine of 3 pi over 4. And again, that just becomes 2 root 2. So I'm facing 3 pi over 4, and I go out a little bit past 2. 1, 2. Just a little bit past 2. And I continue around. Keep going. Let's try pi. And I go 4 sine of pi. Well, what's the sine of pi? 0. So I get 0. So if I'm facing pi now, I don't go anywhere. So my next point's right here. And if you notice, we made a complete circle. So basically, this is a circle. Anything between 0 and pi will make this a circle. And we're actually going to do a lot of these next year in calculus. We'll need these. So what I would like you guys to do is try this one, 3 sine of theta. You know what? Let's make it a little bit more challenging. Let's actually make it cosine of theta and see what that does. So try that one for tomorrow, and we'll take a look at some more of those, okay? All right, let's go on to the next example. The next example we're going to talk about is something that we call Lemma Cons. Now, there are 3 main types of Lemma Cons that we work with in calculus, and we're going to take a look at shortcuts for these in a little bit. So the first thing we're going to do is make a table. It's a little bit different. Notice, the other one was just like 2 cosine of theta. Here we have 2 plus. That's going to change some things for us. So when you make your table, we have theta and we have r. So I pick some value to theta. Pick 0. If I pick 0, I get 2 plus the cosine of 0. Well, cosine of 0, 2 cosine of 0. This becomes 2 plus cosine of 0 is 1. So this becomes 4. So if I'm facing 0, 0, we're out 4. 1, 2, 3, 4. There we go. Now, most of the time, we can just pick the quadrantal angles. So that means 0, pi over 2, pi, 3 pi over 2. So I'll pick pi over 2. Now watch what happens when I pick pi over 2 here. I get 2 plus 2 cosine of pi over 2. Well, cosine of pi over 2 is 0. So what do I get? 2. 1, 2. So I'm going to connect them. Make a sweeping motion. Remember, we're going to make it's curved. Don't draw a straight line. Real functions have curves. We're going to curve it. Next, let's pick pi. If I pick pi, I get 2 plus 2 cosine of pi. Well, what's the cosine of pi? Negative 1. 2 plus 2 times negative 1. And that becomes 0. So I'm here at 0. And now be careful. We don't just draw a line straight down. We can't draw it straight down because remember, it's going around a circle. Okay, so if you need to, pick something between pi and pi over 2. Like you might pick pi over 4. Okay, but what's going to happen is it's going to sweep around and it comes down here, like so. And that's what our graph is going to look like right here. Next, when we graph the next one, let's try 3 pi over 2. Now, 3 pi over 2, go 2 plus 2 cosine 3 pi over 2, and this becomes 2 plus 2. Well, what's the cosine of 3 pi over 2? 0 again, so we get 2. So facing 3 pi over 2, we're going to be at 2 places below. But remember, I'm not going to connect the dots here. What's going to happen is it's actually symmetric. It's actually going to kind of go like so. Like this. And if we pick 2 pi, we get 2 plus 2 cosine of 2 pi. Well, what's the cosine of 2 pi but 1? 2 times 1, so we get 4. So when I'm facing here, it's 2 pi. I'm back out to 4. It's going to go back to our graph. And there's our graph. Now, this has a special name to it. It touches at the pole, at the origin. This has a special name. This is called a cardioid. A cardioid, or a heart. So it's a Lemma Con, but it's called a cardioid. Now, Lemma Cons are anything that has like little bumps on them, like so, or butts, as you can tell. All right, so let's take a look at the next one. Same idea. Let's see if we can graph this one. I'm going to make a table. Now, to help you out, if you had trouble with the last one, I'm going to pick a few more points this time, and that may help you out. Let's do theta and r. Start with 0. 1 plus 2 sine of 0. Well, what's the sine of 0 but 0? So that's just 1. So if I'm facing here, I'm going to go at 0. I'm going to go at 1 unit. That's where I'm going to start. Pick another one. I might pick pi over 4. 1 plus 2 sine pi over 4. Well, that's easy. Matter of fact, let's not pick pi over 4. Pick numbers that will make it really nice. Sine of pi over 2 is at 1/2 at pi over 6. So I'll actually pick pi over 6. And I get 1 plus 2 sine of pi over 6. Now, why did I pick that? Because this is 2 times 1/2, which is just 2. So if I'm facing pi over 6, I go out 2 units, like so. And I'm going to connect them. Now, I'm not going to pick pi over 3. Why not? It's not nice, but I can pick pi over 2. So for sines, I'll pick pi over 6s. For cosine, what do you think we'll pick? So we go 1 plus 2 sine pi over 2. That's easy. That's just 1 plus 2 times 1. We get 3. So we go 3. So we're facing pi over 2. We go up 3. 1, 2, 3. And we go up. Next, I'll pick 5 pi over 6. 1 plus 2 sine of 5 pi over 6. Again, this is just 1 plus 2 times 1/2. So again, this is just 2. So I'm facing 5 pi over 6. I go out 2. 1, 2. And I'm going to keep connecting. Keep connecting. Looks like a circle maybe. I don't know. We'll find out. Pick pi. 1 plus 2 sine of pi. Well, sine of pi is just 0. That gives me 1. So face pi, go out 1. Keep going. Pick 7 pi over 6. 1 plus 2 sine of 7 pi over 6. Well, 7 pi over 6, this becomes 1 plus 2 times the negative a half. Now, if you notice, this becomes 0. Interesting. It's going to it's going to bubble over. You can't really see it very well in this graph, but it kind of goes back, it kind of goes around. Don't draw straight to it. And if I pick 3 pi over 2, watch what happens here. 1 plus 2, that becomes a negative 1. I get negative 1. Here's an interesting predicament. We're facing 3 pi over 2, but we go backwards. So what happens? It's going to go through the axis and kind of make a loop. Like so. Like a little bit of a loop. And if you pick 11 pi over 6, try 11 pi over 6. I ran out of room here. That's going to give me 1 plus the sine 2 of negative 1/2 again, which is again 0. It puts me back down. It has a loop on it. And if you pick 2 pi, that's the same as 0. That's going to give us 1. So it's going to go back to 1 right over here. This is a special name too. This is called a Lemma Con. It's not called a Lemma Cons, it's a really soft S, with a loop. Alright, go try these again and go to part 2 and we'll take a look at a couple more examples.